Good afternoon. Welcome to today's webinar, The Power of 5G and the Fourth Industrial Revolution. My name is Paul Federico, and I'm GCP's Vice President of Corporate and Member Relations. I will be your host today. I'll be in the background taking questions. Please take a second to find the question box. Please use it during the presentation. Type in a question and press enter. This is the only way our speakers will hear from you. And we certainly want to make this as interactive as possible. You're in for a treat today. We have two great speakers, Sanjay Udani and Jessica Cohen, both from Verizon. We're thrilled to be partnering with Verizon as a GCP member company. First we have Sanjay. He's the technology guy who can explain things to those of us non-tech people. He's a technologist who serves as Vice President for Policy, where he develops and coordinates Verizon's policy positions on emerging services and technologies including 5G, cybersecurity, privacy, spectrum, and supply chain security. He also provides technical expertise to help internal and external stakeholders to better understand the technology that underlies ongoing policy debates and discussions, such as members of Congress, various government agencies, senior leaders of Verizon, and Verizon's board of directors. Sanjay frequently represents Verizon in meetings with US and foreign government officials and often speaks at major industry events. Next, we will hear from Jessica Cohen. Many of you know Jessica from her great work around town. She currently leads Verizon's philanthropy and community engagement efforts for the Northern Ohio market. Before joining Verizon, she worked in the nonprofit and public sectors, served on the staff of US Congresswoman Carolyn McCarthy, and later in institutional advancement and government advocacy roles for Cleveland-based nonprofits. During her tenure at Jewish Federation of Cleveland, Jessica became a recognized leader in external affairs and community relations, later serving as Vice President of External Affairs for a Cleveland-based nonprofit technology startup. Please remember to put your questions in the question box and return without further ado, I welcome Sanjay.
Thanks, Paul. Hi, everyone. Nice to see all of you virtually. So I'm going to talk a bit about 5G. I mean, we've all heard lots of different buzzwords and different myths and things about 5G. So I'm going to try and talk through what's real, what's hype, what we're deploying, and what drove 5G to begin with. So before we get into sort of 5G itself, I thought a little bit of history would be useful. So if you think about back in the 80s, when we first started the first generation of voice, cellular voice, we had those phones that basically resembled bricks, if you remember, which you could use as a phone and as a weapon. Those were analog, and they worked, but that's pretty much all you could say about them. They could only do analog voice. Sometime after that, in the 90s, we started doing digital voice. And almost as an accident, we discovered that when you digitize voice, there's gaps in between the packets that are being sent where you could put in text. And that's how texting was born. It wasn't a planned service to begin with. We sort of discovered, okay, we can fill in the gaps with this and we can use it to send messages. And that's what really took off. And this is the early mid 1990s. We still had, devices that were pretty hefty. And then we got to what is sort of more familiar to most of us, 3G. This is the days of the BlackBerry, so the early 2000s, if you remember, when everyone was, using physical keyboards instead of virtual ones. And so with that, you started having not just voice, texting, and email, but you actually had access to the internet. Of course, this was a very different version of the internet than what we're used to, right? So this is early 2000s. There was no video on the internet, and on your BlackBerry, you would click on a link, and about 3 minutes later, it would load, and voila, you have the internet. So not really what we would consider the internet now. And then finally, in 2010, Verizon introduced the 4G service, and so did some of the other carriers. That's when we really started having all the capabilities of your desktop in your hand. So whether you're talking about watching video, whether you're talking about surfing the internet, texting, all of this stuff kicked in. And of course, then we had apps coming in, which changed everything. So this is where we are. Now, one thing to note is that when you're making standards, whether it's for 3G or 4G, typically it's a 4 or 5 year process. So for example, with 2010 deployment of 4G, the standards work started in early 2000s, early to mid 2000s. And what that means is that when you're designing the standard, you have to make assumptions. What's this service going to be used for? So back in the 4G days, right, in the mid 2000s, we didn't have a lot of video, but we did have some. And so one of the things that we knew was, well, whatever this 4G service is, it's going to have to support streaming, right? Video streaming, high-speed data. We knew about that. Latency, which is the lag between what you click on and you get the response, that wasn't as big a concern because no one was really thinking about doing gaming on your mobile device. Again, remember, this is the early days of iPhones, right? The iPhones weren't born when we started designing the 4G standard. And it has to work when you're driving. Okay, that's fair. But since we deployed 4G, what's happened is we've started using the 4G network in ways that weren't really thought about in any significant way. So for example, we now have millions of IoT devices, Internet of Things devices, where you don't need high speed. So for example, think of a utility meter or a bridge sensor or something where you're just sending a message every couple of hours saying, yeah, the bridge is still here. You don't need to have high-speed data. It has to be very reliable, right? You can't have it be flaky. And then, of course, it's not going to be moving, but you want the battery for that to last for months or years. You don't want to have to go and recharge the battery for every sensor that's out there every couple of days. In fact, in many cases, we now see batteries for these kinds of things lasting 6, 7, 8 years. So that's one use case that was sort of new. Another one, gaming, which took off in a big way. And if you talk to any gamers, and I suspect there's many gamers online right now, high-speed data is not as big an issue. That's not the number one priority. The biggest priority is the low latency because you want the interaction to be in real time pretty much. So the low latency part is critical. And then, of course, the session could go on for hours and hours and hours, more than what most people would admit to. And so that's another use case. And then last but not least, and these are just examples, right? You can probably think of a bunch more. This one is, I guess, a little bit ironic given where we are now with the pandemic, but back in the day when we could actually have groups of people get together, if there was any event, whether it's a concert or a speech or whatever, everybody would whip out their phones and start recording and start streaming. So that's a very different use case where you have dense connectivity, huge number of people, huge number of devices in a small area that's taking up a lot of the upstream connectivity. So these are just some of the examples. So these are some of the things that we started using 4G for that weren't really thought about in any great detail. And so when we started designing 5G, we took into account these things and potential future things. Now, I guarantee you we haven't thought through all the different possibilities of what 5G will be used for. But some of the ones that we've considered as we designed this, right? So the 5G standard started in the early 2012, 2013, 2014 timeframe. Some of the capabilities that we've included, high data rates. So you can go up to 10 gigabits per second, which is 10,000 megabits per second. Just to give you some context, if you're watching Netflix or YouTube, that stream on your handheld device is probably going to take maybe 1 to 3 megabits per second. So we're talking data rates that are obscenely high, even for your home broadband connection, much less a mobile device. Another one is the device density. And the volume of data. So this is where it gets interesting. This is for, you've got a stadium full of people, all of them streaming at the same time, right? Current networks, whether it's Wi-Fi, 4G, can't really handle that. With 5G, we've designed it so that in a space of a square kilometer, you can have up to 1 million devices all connected and streaming at the same time. So that's a big, difficult challenge. Another one is the low latency, and I'm going to talk about this in a little bit, so I'll kind of hold off. But suffice to say that without the low latency part, a lot of the future things that we've been talking about, augmented reality, virtual reality, interactive, anything, don't really work well. And then there's a whole bunch of other areas that I'm not going to focus on. One of them is security. things like network slicing, things that enable 5G to now securely create groups of services based on the use case. So the way I would think about 5G is that it's not one network. It's a different kind of network based on what you want it to be. And this is the first time where the network will adapt to what your service needs. So up to the time of 4G, in general with consumer networks, it's been, okay, here's what the network can do. And if you're writing an app, you basically have to adapt to it. You don't really have a choice on, do you want low latency? Do you want high data rate? What makes your app optimal? To do all of this, um, here's what 5G uses, right? So the key things are fiber, lots and lots of fiber. And the second one is spectrum. We are very greedy as an industry. We will take all the spectrum we can get, because without spectrum, we don't have any connectivity to your devices. And then we have software-defined networks and sort of making the network smart, basically. And then last but not least, the mobile edge compute, which I'll talk about in a bit. So those are the sort of the big things. And I'll pause here, Paul, in case if there's any quick questions or clarifications that we need.
Nothing right now. We're good.
Okay, great. All right. So let's talk about how networks have evolved, right? So I mentioned going from 2G to 3G to 4G. The one thing that's been the same since the 1980s is the way we connect from your device to the network is basically you've got this big cell tower, which we've all seen and driven by, 200 or 300 feet tall. And that, it doesn't matter if it's 2G or 3G, it's the same method. And then on the back end, we've got the network equipment, that's the blue circle, and then we connect to the internet. With 5G, there's two physical things that change. First, it's no longer just the big cell towers. We now have, we're changing the radio access network, the connection between your cell phone and the cell tower. And we're now adding a whole bunch of small cells. And I'll give you some pictures of those in a little bit. So we're now changing the physical layout of the network. And then the second thing we're doing is we're adding the MAC, the mobile edge compute. So I'll address the first one first, adding the small cells and the use of spectrum in a different way. And then I'll talk about the mobile edge compute. So for the spectrum part and the small cells, if you think about, and you might have heard the analogy, spectrum as a layer cake, low band, high band, mid band. Now I could spend an hour on this, but I'll kind of give you a one-slide summary. So the way spectrum works, the frequencies that we use, anything that's low band, that's less than 1,000 megahertz, is considered low band. So, and then there's mid band that's between 1,000 megahertz and 6,000 megahertz, or 1 to 6 gigahertz. And then finally, anything above that is considered to be high band. So if you just kind of look at the drawing, I drew it that way on purpose, right? Because low band, there's not a lot of it, because it's between 0 and 1,000. The mid band is between 1,000 and 6,000, so you've got more of it. And then finally, of course, the high, you've got way more of it. The characteristics are that the low band spectrum tends to go much further. And this is true for cellular as it is for your FM radio, for your TV, right? You put an antenna up and you can cover half the state with one antenna. That's just the way the spectrum behaves. The catch is, of course, there's not a lot of that spectrum, so you can't carry a lot of data on that. Midband is sort of the sweet spot where it gives you decent coverage, not as good as the low band, but a decent coverage, and there's enough of it that you can actually do some reasonable capacity. And then finally, you've got the high band. Sometimes some of it is referred to as millimeter wave spectrum, same idea. We have a ton of it. The only catch is it doesn't go very far, and it doesn't penetrate things like buildings and walls and windows. So each one of these has different characteristics, and it gives you different benefits. And so as we design the network, it's no longer a question of, well, we get spectrum and we build it. It's let's design the network using spectrum based on the use case. And that's where it gets a little bit more complicated than just, deploying a cell tower. So I'll start with the traditional cell tower, right? So we've all seen this, a couple 100 feet tall. And the way it works is you put one cell tower and it covers one sector. So I'm just showing one of the 3 sectors it covers. So, the gray is the coverage. It's low frequency, so it covers a lot of area. So, there's a bunch of buildings here. coverage is great. The problem is that if you have a lot of people in this space all trying to do something, stream video, you just don't have the capacity. On the other side, or the flip side, you've got 5G with higher band spectrum where the coverage, because it's higher frequencies, is not so great, right? So this is sort of more like the orange circles that I'm showing here. So you need a lot more of the small cells to provide coverage to all the different buildings in this case. And also you need a lot more fiber to connect all of these small cells, because without the connection, the small cell is basically just sitting there doing nothing. And so one thing to note is 5G is not replacing 4G. 5G should be thought of as an enhancement to 4G. So in this case, you can see that even though you've got a whole bunch of small cells, it's not enough. You still need coverage in the rest of the area that might not have the coverage. So you're going to have 4G and 5G both working together. And so a key thing to note is that for the foreseeable future, every 5G device is also going to be a 4G device. It's going to have both, because you're not going to have 5G in every single location. And this is true not just in the US, but globally. So this is the sort of the way we're thinking about 5G. And like I said, this is one of the times where we start thinking about spectrum, not just as a way to access the customer, but also we now deploy it based on the service. So if you think about the high band spectrum, where it doesn't go that far, but it gives you lots of capacity, where's that going to be useful? Well, everything from an urban environment to maybe a stadium. And I think Jessica's going to talk about that, where you have a whole bunch of people all clustered together. So that it's great for that. On the other hand, if you have a whole sort of a wider distribution of people, if it's not as dense, well, then you use the low band, and in some cases the mid band spectrum, because that gives you the best coverage and it'll provide enough capacity that everyone gets the service they need. So it's not a question of is low band better or high band better, or whatever. It's just, what's the service you're trying to deploy? How much capacity are you trying to do?
Sanjay, a quick
Yeah.
question that
Yep.
relates to the Spectrum Hub we were talking about earlier.
Mm-hmm.
So with all the power outages today in different areas,
Mm-hmm.
how does that affect coverage? Is it different with 5G versus others, or can you talk about that a little bit?
Sure. Great question. So this is another one where you're right. With an individual small cell, and these are typically mounted on a pole, a lamppost, or something along those lines. If there's a power outage in that neighborhood, it's going to be difficult to have battery backup for every single small cell. There might be some cases where you do, but in general, it's going to be hard. So if there is a power outage, that small cell goes down, well, you still have the bigger, lower frequency tower that's giving you coverage. So you do have a backup of sorts, right? So that's the way to think about it, that these are going to be very specific to a given area. Whether it's a stadium or whether it's a neighborhood, and then you'll have backup using the 4G capability. Any other questions?
That's it. Thanks.
Okay. All right. So just to give you an idea of how fiber intensive these deployments are, and this is just for Verizon. We're deploying with Corning and Prismian 47 million miles of fiber. We're in the process of deploying it. That's roughly enough to make 100 round trips to the moon. Interestingly, I think Nokia just announced that they're planning to build a small cell site on the moon, which I don't quite know how they're going to do that, or how they're going to string fiber there, but I guess we'll find out. So that's just one. Fiber is a huge component of deploying 5G. And then the second one is that in the areas we're using the high band spectrum, the millimeter wave and sort of the higher frequencies, we're going to deploy a lot of these small cells. Now, these are very different from the ones you're used to seeing on cell towers. I mean, those are huge. They're bigger than a person. These are relatively small. And these are just some examples. The designs are evolving to kind of fit with whatever is out there. I've seen ones that fit inside a kiosk. The ones that you're seeing in the picture is the brown ones in the middle. So these are all sort of designs that are changing, but you can see they fit in much better than, say, your typical tower. So those are from a physical perspective, those are the two big changes that you see. Another thing we're doing is the 5G home. So this is meant to be a broadband to the home, to replace your cable service. And the way it works is it's very similar to what we're doing with 5G and our sort of small cell deployment. In the neighborhood somewhere, you'll have a 5G small cell. And in your home, you'll have basically a glorified smartphone without a screen where the modem, the home router, has a 5G chip in it. So it takes the 5G signal and converts it to Wi-Fi, and all the devices in your home are connected. We've deployed this. I forget the exact number, but I think it's tens of cities at this point, or in areas of tens of cities. And customers are seeing speeds in the 6, 7, 800 megabits. Some are hitting a gigabit. So this is definitely competitive with any broadband that's out there. The nice thing about this is you don't have to put a fiber or a cable to every home. So that makes the installation a lot simpler. And that's going forward, that's going to be a big deal because again, the more homes you have to go to and dig and put fiber in, or fiber or cable, it's more complicated and expensive. This is a map, and you can go to verizon.com/coverage-map to get the latest one, but this is from a few days ago. It shows you where we have the 5G ultra wideband. So that's the high band spectrum that I talked about. Now, to be fair, this is not covering the whole city. It's covering parts of the city because it's a very intensive build out, right? You saw that we have to put in small cells every couple of blocks. And so this is not going to happen overnight. And so when you see the media saying, well, 5G is not happening quickly enough, well, yeah, because this is not just something where you can flip a switch. It's not an app where you load it to the App Store and now it's deployed to everyone. This is, building out stuff. In some cases requires digging. In some cases requires putting small cells on hundreds, if not thousands of poles. Then the areas that are in darker red, that's the 5G nationwide. And so that's a hybrid 5G and 4G service. And what we've done is with our existing antennas, we've modified them so that if you have a 5G device, that antenna, the cell tower will connect using 5G. If you have a 4G device, it'll connect using 4G. And so it doesn't look like it's a lot as far as the red shading, but actually it covers over 200 million of the population. And then the orange is the 4G LTE, and then you've got the gray, which is 3G and so on. So this is just to give you an idea. Like I said, it's still early days for 5G. I'll pause. Any questions, Paul, before I continue on to the Mac?
No, you're good to go.
Okay, cool. Either everyone's completely understanding everything I'm saying or everyone's asleep. All right, so this is just your basic diagram. Again, you got a smartphone connecting to a small cell and then going to the rest of the network. And what we've added is this thing called a MEC, mobile edge compute. You might hear someone refer to it as a multi-access edge compute. Same thing. It's nothing fancy as far as physically, it's just a computer. It's a rack-mounted computer that can do local computing and storage, and you have specialized software on it that lets it do a bunch of different things. And it's meant for shared or public or private use, so shared or dedicated use, and we'll talk about that. So why a Mac? Well, if you think about how the internet has evolved, in the early days of the internet, if you were trying to connect to a website, say Netflix or CNN or whatever, that server could be hundreds, if not thousands of miles away from you. And it wasn't a big deal because for most people, we were not doing anything interactive. We were clicking on a website and getting a page, and then you read it for a few seconds, and then you click again, or maybe you're streaming something. Latency wasn't an issue. The catch is that what we're discovering is that the speed of light is not fast enough. It takes roughly a millisecond for light to travel 100 miles in fiber, which is pretty darn fast. But the catch is, of course, if you're trying to do something interactive, that might not be good enough. So in the early days, the servers could be thousands of miles away. Nowadays, if you try to stream, say, Netflix or something, chances are you're going to be pointed to a server that's closer to you. Could be hundreds of miles away, but again, like I said, the latency isn't as big a deal if it's not interactive. what we've discovered is that if you're doing virtual reality, augmented reality, anything where you're putting on the headset, the goggles, um, unless the latency is in the single-digit milliseconds, 3, 4, 5 milliseconds, um, if you don't have that, people tend to not feel as immersive an experience. And in some cases, people can start feeling sick because there's a slight lag between what you're doing and sort of what you're seeing. So your brain gets confused. And so what we're trying to do with this is we're now bringing the Mac even closer to you. So we're deploying Mac in a way that it's hopefully roughly 100 miles or less from customers. And we can increase the density as the sort of the services increase. But the idea is to make it so that it's less than a millisecond away from you. And what that does is that with all the processing, everything, the latency should be in the single digit milliseconds. And that's what enables a lot of the interesting interactive stuff. So that's the rationale for the Mac. Um, one example I'll use, and this is Microsoft's Hololens. Very cool. You've got a doctor and a bunch of students all looking at a virtual patient, and they're kind of performing virtual surgery and so on. Really cool. But to make this happen on any scale, right? So with interactive games, you can do it with a few people, but if you're trying to do this in any scale, how would you do it? Well, imagine a scenario where for a hospital, you've got a Mac built in the hospital, and now you've got the doctor and a bunch of students, right? They're all taking part in this. And now the interesting thing here is that because all the processing is going on in the hospital itself or close to it, there is virtually no lag. So any movement they make, anything they do onto that the virtual patient will feel as if they're doing it in real time. And that's the critical part. Um, as long as it's within the same city, if one of the students couldn't make it in that day, they could still do that because you could have a Mac that's in their part of the town, and they could still participate and they really wouldn't notice much of a difference. So this becomes a very interesting case where if someone can't physically be there, they could still be there. Um, So I mentioned earlier that we're looking at private and public sort of shared and non-shared applications. So one of the Mac applications we're looking at, and this is a partnership we announced with Amazon Web Services, is that you would have a Mac that is shared by anyone. So you could have an app writer writing an app on the Amazon cloud that would use our Mac for low latency connectivity. So that's something that can be used by homes, mobile phones, whatever. Another one, and this is actually to me a very interesting one, is a private Mac. I mentioned the hospital just now. It could be a hospital, it can be a factory, it can be a military base, it can be whatever you want it to be. Some sort of a closed environment where you have the Mac there, and now it's doing all the processing and storage locally. Now that has some security implications, some security benefits, but in terms of the capabilities, now you don't have to fix your equipment using wired connectivity, for example, in a factory. You could now have all of your devices, all of your smart devices and robots be easily movable because they can all be wireless. There is no longer a factory with a fixed floor where all the wiring is done. It's completely flexible, right? So that opens up a whole bunch of possibilities. And I'll mention a couple of them towards the end here, some ideas. But like I said, this is still very early days. We are setting up labs to kind of play around and see what else we can do with this because this is a new capability. Up to now, in a general consumer network, we've never had this capability to have ultra low latency. And so this is still, like I said, early days. So one example, this is in one of the warehouses that Verizon uses for distribution. What we're testing out is having a sort of a computer vision where you've got the workers who are loading in the smartphones and other devices that we ship, but in real time, the robotics are looking at what is being packed to make sure that it's accurate, right? So instead of having a second person or a second check, you're now doing this as the box is being prepared so that okay, you've got everything that's correct in there. And so the shipping becomes faster and it's more efficient. Another one, training technicians. Imagine this scenario, right, where you've got a technician who's out on the field And now they put on these goggles, and not only can they see what the actual equipment is supposed to look like, right, the wiring or whatever, but also if they need help, they can have their supervisor dial in, and now the supervisor can see exactly what the worker is seeing. And I'm using this as an example, but you can think of any application like this, where whether it's teaching or whether it's um, uh, in a factory, anything that's interactive, this enables. So one last application, and I'll stop. And this is just an idea, but just to give you an idea of the things that are possible, right? So a while back, I was talking to some educators in Connecticut, and they were saying, and I did not know this, that apparently a lot of the students who live in rural areas in Connecticut are in a school bus for up to an hour each way. And the entire time they have no connectivity. And so what if you could now put a Mac in a school bus, right? And again, remember, Mac is just a small computer, right? It's not anything magical. And so while the school bus is on the rural road, the students could be doing their homework, right, as if they're connected. And then when the school bus finally reaches the school, all the data gets synced up seamlessly into the cloud. And so it's as if the students never lost connectivity. Now, we're still a ways away from this, right? I mean, this is still early days, but these are some of the things that open up the capabilities when you can start, sort of thinking about how do I use this capability. So I'll stop here, and I think Jessica, I believe you're next.
Yes, thanks, Sanjay. That was great. I've heard this before, but every time I get excited about 5G, I wanted to share that, as we know, so much talk about 5G. It's great to get a deep dive and some use cases of how it could transform our city in the future. But I'm sure that many of you may be asking, is 5G here in Cleveland already? And the answer is yes, in part. And I'm going to take just a few minutes to share that with you. Thanks for moving on to the next slide, Sanjay. So 5G launched in Cleveland in December 2019. It made Cleveland one of the first 30 cities in the country to boast a Verizon 5G, which I was pretty excited about as a Clevelander. And then also in December, and this is the picture you're seeing right here, as part of our investment in the Cleveland market, Verizon launched the Verizon Innovative Learning 5G Lab. So this is at ePrep Cliffs, which is a breakthrough middle school at East 36th in Superior. They're home to the lab. It was the first Verizon Innovative Learning 5G lab in the entire country. So, Sanjay referenced labs where kind of testing and building all across the country. So this is our first 5G lab for education purposes. The lab has 3D printers, 2 virtual reality stations, and other cutting edge technology to allow for more immersive collaboration for students and teachers. And it's turning lesson plans into living, breathing, dynamic experiences. This lab is part of Verizon's overall commitment to digital inclusion, and we're helping to enable individuals and communities to develop the knowledge and skills to thrive in the digital age. Exposure, this is, as I said, it's a middle school, so exposure to 5G technology in the lab at this level empowers students to become lifelong learners, creators, and problem solvers. It also allows students to get early exposure to the latest in technology, making 5G, something that's new to most of us, very normal to them. In fact, they've been using it now for about a year, although it was interrupted by COVID. This lab is part of Verizon's broader innovative learning program that's helping under-resourced communities bridge the digital divide since 2012. As you might imagine, 5G is an intrinsic part of this because digital literacy needs to extend to the newest cutting-edge technologies. Sanjay, could you get the next slide for me, please?
Sure.
So all of us on this call knows where this is and what this is, First Energy Stadium. And yes, 5G is there. So if you were freezing, one of the few thousands of people that were freezing at the game on Sunday for the win, you would have been able to access our 5G network there. When we were one of the first 30 cities, First Energy Stadium was the 15th NFL stadium in the country to have 5G mobility service. And as Sanjay mentioned, 5G connectivity is critical to providing the user experience we all need when we're in large crowds and an exciting event. So We're not there now, but in the future, when we return to large crowds again here in Cleveland, whether it's a Browns game, another World Series run by the Indians, a Rock Hall induction ceremony, or even the upcoming NFL draft taking place right here in Cleveland in 2021, Verizon 5G is here, and it will be here, ready to keep Clevelanders and visitors alike connected and sharing with the whole world why Cleveland rocks. Next slide, please, Sanjay. So as I mentioned, as I described, 5G is here, but it's really up to Cleveland and all of us to put it to work. 5G wireless networks, as Sanjay described, can put connected devices and platforms together to boost local economies through better services and improved efficiency of operations. So I just want to give a few examples of how this could be deployed locally as users take this on. One, smart city buildings allow for reduction of energy use and emissions through automated HVAC controls, energy use monitoring, and managing smart grids. And we know with the crazy weather here in Cleveland that any way that we can better control our HVAC and our climate within our office buildings would be a huge benefit. Number two, efficient allocation of energy optimizes the ability to accommodate the use of solar power and other alternative energies. We have a burgeoning alternative energy industry here in Northeast Ohio, so this is critical. Number three, the use of integrated video monitors for police allows real-time remote monitoring to reduce crime and solve missing persons. And this goes hand in hand with acoustic sensors on a 5G, which detects gunshots and immediately notify law enforcement and first responders. 5G also enables the real-time monitoring of water and energy use to allow conservation and the ability to proactively identify maintenance needs of systems, reducing downtime and cost of operations. And lastly, smart transportation projects make fleets, intersections, highways, transit hubs, and beyond safer and more efficient. Now, we don't have terrible traffic in Cleveland. I'm from New York, so I excited every time I get on the road here, but we do have some traffic. And so this would make things much more efficient and also better for the environment. And smart utilities initiatives help communities reduce energy and fuel costs, achieve environmental goals, and meet the needs of growing populations. So all of these are just possibilities. We at Verizon certainly hope the Cleveland community will explore ways to engage with Verizon 5G technology as early adopters and users. I'm happy to be in touch with anyone after this presentation if you'd like to learn more. And so I will close by saying thanks so much again to GCP for allowing us to share more about 5G. And I'll turn it back to Paul if we have any questions.
Yeah, one question came out a little earlier I missed is potential disadvantages of 5G or challenges that you have as you're implementing and putting it all together?
Oh, well, great question.
I'll let Sanjay take that.
Yeah. That's a great one. So, there's a lot of different layers there. One is global competitiveness. So, we are in a race to deploy 5G. So just like with 4G, we were the first country to deploy 4G in a massive manner, and that led to us leading the way in a lot of the developments that came from 4G. Whether we're talking about the app stores and those kinds of things to the gig economy, all of those things were driven by the technology that we deployed first. So in that sense, we are competing with the world. And obviously China and others are being very aggressive with 5G also. So there is a race going on there. And so the sooner we can deploy this, the sooner we can get things going. And so it's always a challenge in sort of clearing the path to, making sure you can deploy the small cells, making sure you can deploy the fiber, you're making sure you can get all the spectrum. So that's a challenge because that's very different than how we deployed networks before, right? Because now we're talking about instead of one big cell tower for maybe half a city, we're talking about thousands of small cells. Getting permits, getting the rights of way, all those things that Jessica and company deal with. I think those are challenges for deploying 5G. The second is having people understand that a lot of the hype about 5G. It's just that right now. It's just hype, but it doesn't mean that it's not real in the future. Everyone's kind of going, well, I have a 5G phone. It's not doing anything right now, so it's not cool, right? Yeah, right. I mean, right now there's not a lot of interesting use cases, but it takes time, right? This is very early days, but the problem is that there's been so much hype that if you don't have something tomorrow, everyone assumes that it failed. and that's simply not the case. So those are just two that come to mind.
Another technical question, or more technical, is 5G very similar to fiber optic? Will one replace the other, or how does that work?
That's another good one. So this is the 5G home that I mentioned, where we are connecting to consumer broadband to your home without using fiber or cable. It is comparable. So fiber has essentially infinite capacity, so it's going to be impossible to beat. But as far as your traditional broadband deployment, yeah, 5G home is as good, if not better, than most other broadband that is out there. And so that's one of the big things that is a huge benefit. In fact, our CEO just was, I think, talking yesterday, and he said that on average, the install for a 5G home is taking, in some cases about an hour. And in 70% of the cases, consumers can do a self-install. Think about the last time you had, a cable company or someone come out to install stuff in your home and how long it took, right? So, there's huge benefits if we can get this going in scale. We have it in, I think, about 20 cities right now, and we can confirm that, but it's somewhere in the 20, 30 cities range.
Yeah, and I'll add, it's not in Cleveland yet, but it's, as Sanjay alluded to, it's a great advantage for urban populations that are highly mobile. And so you don't need to rely on any wires, to your home or apartment. It's internet service, the broadband access that you can have, wherever you are, and then take that with you if you move. And so that'll be an advantage in urban areas when it gets here to Cleveland.
Great. The only other questions I have are for around the lab. Is that something that people could use or go to, or what's the advantage of that?
Yeah, it's a great question, and unfortunately, COVID has stymied many of our plans for 2020 with the lab. We are, as soon as it's safe to do so, we're thinking about ways that we would be able to host different events or groups in the lab. That will not be the only 5G space that Verizon is creating in the city, so stay tuned this spring for more information on that. But I would absolutely be the point person for that, and I can put my email in the chat, and I would love to connect with anybody who's interested in engaging with the lab in some way to look at the possibilities of 5G in their industries.
Perfect. I see a few questions in here too about maybe doing another one down the road a little further when 5G is getting more involved here. So that could be something we can maybe bring you guys back.
Sure.
Thank you both for really an educational program today. I really learned a lot. Thank you for that. And we all appreciate it. And without any further ado, I just want to thank Verizon for being involved with us and all the great work you do. We love working with you. And without further ado, I think we're done for the day.
Okay, thanks, Paul. I'll just say that I don't think I can send a message out to everyone, but Paul has my email. It's jessica.cohen@verizon.com. So feel free to get in touch.
Perfect.
Thanks, Paul.
So much.
Thanks, everyone.
That ends our webinar. Thank you.